this episode we are on to complex numbers. A complex number is a number which comprises of a real part and an imaginary part. So a complex number is generally expressed in this form. So this is your real part, and that is the imaginary. So you have the real part and the imaginary part. And remember, I is equal to the square root of -1. So we want to do addition and subtraction, complex numbers, and then also multiplication and division. So let's say you have your complex number 3 plus 2i, it's complex number u. Complex number v to be 1 plus I. So addition u plus v will be equal to 3 plus 2i plus 1 plus I. So that will simply just be real numbers. 3 plus 1, that's 4, then the imaginary part, 2i plus I, that will be 3i. First part, then part 2, subtraction u minus v, will be 3 plus 2i minus 1, so that will be 3 minus 1 minus I. So 3 minus 1 is 2i minus I, is plus I. Part 2, multiplication, u times v, that will be 1 plus I, 3 times 1, that's 3i, plus 2i, plus 2i squared. So that gives us 3 plus 5i, 2i squared, I squared, and like saying I is equal to square root of -1, so I squared will now be -1. So we get -2 here, 3 minus 2 is 1, that's 5i. Division, onto division, number 2, part 2. So u over v will be equal to 3 plus 2i over 1 plus I. So for us to divide complex numbers, the denominator, the conjugate, is what we call a conjugate, which can be expressed as the dx. So the conjugate of v of any complex number will be, say for example, in general when you are given a plus bi, the conjugate will be a minus bi. So the conjugate of v will be 1 minus I. So we multiply both the numerator and the denominator with the conjugate of the denominator. So u over v is equal to 3 plus 2i over 1 plus I multiplied by 1 minus I over 1 minus I. So the numerator becomes 3 plus 2i 1 minus I over 1 minus I. Remember, the objective, we want to eliminate the complex number from the denominator. So we multiply the numerator, becomes 3 minus 3i plus 2i minus I minus 2i squared equal to plus 2 over the denominator becomes just capitalizing on difference of two squares. 1 plus I, 1 minus I becomes 1 squared minus I squared. So 3 plus 2, that will be 5 minus I over 1. I squared is equal to -1, so it becomes minus. So that will be 5 minus I over 2, which can now be written 5 over 2 minus I. So we have done addition and subtraction, multiplication and division of complex numbers. The last part will be representation of a complex number on an Argand diagram. diagram. So for us to represent a complex number on an Argand diagram, we are required first to understand the modulus and the argument of a complex number. The modulus will be the length of the complex number. So modulus of any complex number, say for example, if it can be written as that. So to get the modulus, get the real part squared and the imaginary coefficient squared. So we're still sticking to our complex numbers. So if you are to find the modulus of u, the modulus of u will be equal to the square root of 3 squared plus 2 squared, that will be 9 plus 4, which is 13. And then the modulus of complex number v will be equal to the square root of 1 squared plus 1 squared, which is equal to root 2. That's how we get the modulus. How about the argument? The argument will be the angle. So the argument of any complex number, say our complex number, that's a plus bi in general. So the argument will be equal to a plus bi will be equal to arctan the imaginary part b over the real part a. So in our case, argument of u will be equal to arctan 2 over 3, the imaginary part over the real part. So arctan 2 over 3. And then also the argument for v, arg b will be equal to arctan 1 over 1, which should be equal to 45 degrees. And for the argument of u, let's make use of the calculator. Argument of u will be arctan 2 over 3. Arctan 2 over 3 will be 33.7 degrees. 33.7 degrees. So representing now the complex numbers on an Argand diagram. In Argand diagram, we have the real axis and the imaginary axis. So starting with complex u, 3 units along the x-axis and then 2 units along the y-axis. So we have 2, 3. The angle, argument with the angle formed between the real part axis and the complex number. So our argument for u is 33.7. So this angle will be 33.7, and then the modulus of u will be equal to modulus of u will be equal to 13. So that's how you represent complex numbers on an Argand diagram.